This episode is sponsored by my online training portal, which is designed by me to help you become a building forensics badass. You can get free access right now at buildingperformanceworkshop.com. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Today we're talking about trends in high-performance building and retrofits from the HVAC angle with Russell King of Sierra Building Science Incorporated. I will not spend the next 15 minutes describing all of the things that Russell has done and all of the boards that he serves on as the chair of. But Russell, let me just thank you in one package for being here to talk with us today.
My pleasure.
In your mind, where are we at right now in this industry?
It certainly has come a long ways, especially in terms of diagnostic testing of existing homes. Unfortunately, HVAC design has not come a long way since I first started doing it back in 1988. It's still an uphill battle to get contractors to do the calculations and do them correctly. But as far as overall home performance, energy efficiency technologies, I'm excited about how far we've come and where we're going.
Let's talk about the design element for a minute. You said that the installers are not doing the calculations, and I think that the two main ways that I generally see these calculations done by the actual contractors is either on paper or as a block load. Can you talk about those two options and about why you might or might not recommend them?
The most common HVAC design method is trial and error. They'll do a design of a house, and after it's built 6 or 8 months later, they start getting complaints about it, and then they'll make adjustments. And typically, the adjustment has been to increase the size of the equipment, and that has led to oversizing of the equipment. I would say it's pretty safe to say that the average house in California, that the equipment is oversized and the ducts are undersized. And obviously that leads to a lot of problems. And then the problem, obviously, with duct loads is you're not putting the air in the right place in the house when you do a block load, because you really need to do room-by-room loads, especially in a 2-story house, to make sure that the air is being distributed proportional to the room's load.
And doing it on paper is different because you're not doing it over 8,760 hours with the benefit of a computer.
It can be done on paper. The hardest part about doing it on paper is if you want to do room-by-room load calcs, then basically every register needs its own calculation. And then it gets to be quite a bit of calculations. But I mean, back in 1988, that's how we did it. We did Acromanual JS&D using handwritten worksheets, and they were printed in light blue ink so that you couldn't photocopy them. You had to buy these worksheets. You had to buy a batch of them, and you couldn't photocopy them and use them over and over again. That was how Acro made some money on the.
That's the real deal, man. I like that.
Yeah.
Well, in my experience doing the room-by-room load calcs with a computer, I found that a lot of my clients are making huge mistakes, and I've even gotten onto Energy Star homes about doing this, is that they don't include the architect's placement and sizing of windows into the whole equation. And I've noticed that I'll get a huge spike in one room at 4 p.m. In the summer afternoon, and that I just think, oh man, wouldn't there be a cool way if we could just limit the amount of windows and the placement of them? And of course, you are now living through that because in California, you have something that takes care of that, right? Doesn't the Title 24 now incorporate window limits?
It does in a way. What they call the standard house, which is the house that sets the target for compliance to the Title 24 Energy Code, has a fixed amount of glass in it. And if you want to build a house that has more glass, you're penalized for that, and then you have to compensate and trade off to bring it back into compliance by using better windows or being strategic in the placement of the windows or overhangs or special energy features that often trigger HERS verification, like tight ducts. And well, that's actually a mandatory measure now, but things like what they call QII, the Quality Insulation Credit, where you get extra credit for installing your insulation extra well.
Not just good, but real good. So
Yeah,
in my
exactly.
mind, though, that window, that the limiting the size of the windows and the orientation of them, which I think in the Title 24 now with the update, it's 20% of the window to floor ratio, and then there's a limit on the west-facing windows. That sounds like it would be a good thing to me. But what's the actual experience on the ground?
On the ground, they design a house however they want the house to be, and if they've got a really nice west-facing view, they'll put the vast majority of their windows facing west. And what the software does is the software does two computer simulations, and the first one is what they call the standard house, and that is the house that has 20% total glazing and 5% facing west. And it does an annual energy simulation on that house, and it spits out a number. It says, okay, in 1 year, this is how much energy your house is going to use. And then the actual house, the proposed house, it's the same size house, and it has the glass however the architect designed the glass to be, and it does a simulation on that house. Now, if you have a lot more west-facing glass and a lot more total glass, obviously that house is going to use a lot more energy. And so you have to trade off. You have to say, okay, well, if what can we do to bring down that energy use down to the energy use of the standard house that's built to the prescriptive measures? And it usually entails putting in a much better window, a much better water heating system, a much better heating and cooling system, and things like that. So it's all about these trade-offs. And I call it the energy buffet. It's like you're going through line and you're picking and choosing these energy features, and you put them all on your tray, and you take it to the cashier, and the cashier says, oh, nope, that costs too much. And so you get back in line, and you take some off, and you add some back on. And, some of those features are glass area and facing a certain direction, and some of those features are better window, shading coefficients and things like that. So it all gets stirred up in a pot and spits out a number, and, the energy use of the proposed house has to be less than or equal to the energy use of the standard house.
So to use your analogy, it sounds like the state of California had decided that it was going to teach people to eat the right amount of food and to eat healthy, and instead what's happened is that people will still eat what they the kind of things that they want, but then they'll trade off by buying a lot more solar or water heater or whatever. Is this the kind of thing that people will rebel against once they figure out that they're paying way more? I mean, they're not following what the incentive would be, which is to design a house the smart way. They'll still do it the way they want, and now it's way more expensive. Are they going to rebel and kind of repeal the code? I mean, is there any worry about that?
Well, what has happened is the standard house, the house that sets your target, has gotten more and more strict. And as every code cycle, every 3 years or so, that target gets more and more strict. And so the house that you build, they do have to compensate, and they've learned over the years. I mean, up until recently, everything you could make it pass with the low-hanging fruit, the high-efficiency equipment, the good windows and stuff like that. But now it's getting more and more complicated, and now it's getting to the point where they're really starting to adjust their design. They're starting to say, gosh, this Mediterranean style with no overhang is costing us, so maybe we should start, trying to factor in some kind of an overhang, recess the windows into a wall, and it's finally starting to affect the design of the house, the aesthetics of the house. It's taken a long time because, like I said, all the low-hanging fruit's been picked, and now they're having to start to resort to some pretty elaborate extra credits that require pretty extensive HERS verification and diagnostic testing and things like that. So we're starting to see architects really, start to adjust their design strategy, I think.
Do you see the fact that everybody else is going to auto-adoption, in some cases, like in my state, of 2012 IECC and then 2015 IECC as going to follow in California's footsteps, or do you think that California has taken a long and circuitous path to end up at the same place that we all will get to eventually?
California has really committed to something that is going to be very difficult for them to change course. they've built this huge, gigantic aircraft carrier, and it's going to be very, very difficult to steer. And it's going to take. People have predicted for years that the California Energy Code is going to implode under its own weight and complexity, but it has managed to keep on going, and they just keep sort of adding little arms and appendages to it, and it's quite a beast. There's 3 documents. All of them are well over 400 pages. Last time I checked, I think one of them is 950 pages, and it's going to take a pretty drastic change to get California to kind of throw it all away and start over with something that the rest of the company, even no matter how well tested and how proven it is, it's going to be tough. It's going to be really tough.
Wow, interesting. I can't wait to see what happens. So let's change tack for a minute. You were a mechanical engineer for the TV show Extreme Home Makeover. What was that like?
Oh, yeah. That was a blast. That was quite a while ago, and it was 2 families that lived next door to each other, 2 large families, and one of the parents passed away, and then the mom passed away shortly thereafter. So there's this large family of kids that basically became orphans, and the next door neighbors were a large family, and they were friends, and they adopted all the other kids. So it was this huge family got combined all of a sudden, and they basically knocked down their house and built this giant house. I think it was 8 bedrooms or something crazy like that. And they took 2 days to knock down the house and 4 days to build the new house, including filling in a swimming pool. So I was on site. There's months and months and months of meetings and preparation go into.
Oh my God! Thank you for saying that. I was getting worried for a second there.
Yeah, it's insane. It's insane. I've sat in meetings where there were probably 30 people in the room, designing this house and getting it all squared away so that they could build it. And they rented a warehouse, and they built all the walls and the trusses and everything in this warehouse. So they basically trucked out the parts of the walls and assembled this house in pieces. And most of my work was designing the heating and cooling system, and it was all done prior to construction. And I was really just there to make real quick field changes, in case something didn't fit. But man, it was, everything was 3D AutoCAD, and we knew where all the beams and the trusses and everything. The only thing we really had problems with, I think, was the kitchen hood exhaust fan or something like that. It hit a beam that we didn't realize or something like that. But it was a fantastic experience.
Wow.
It was exhausting, but really, really fun.
I've always wondered, did you donate your time to that, or was everybody paid?
At that time, I worked for a company called Console, and one of the big sponsors was Party Homes. It was a large production home builder in Southern California, and they Console pretty much donated our time to Party Homes, which is one of our big clients. But I got paid.
Good for you. That's the way to do it.
Yeah, but it was fun, and I enjoyed every minute of it.
So moving forward into the future, it seems like the HVAC installer, everyone is kind of agreeing at this point, is the central player in everything that's going to happen in existing homes and in new homes moving forward, because it's the one piece of system machinery that is the most gotten wrong. It's the thing that people are going to call out immediately if they have comfort problems or odor problems, and that's the person who is already in front of the customer twice a year. What are you seeing happen in that industry to kind of take advantage of these new opportunities? Or what do you wish you were seeing happen?
Yeah, what I wish would happen is that the systems were designed to where people would just forget about them. But that's obviously a dream. As I mentioned, the average house in California, the equipment is oversized and the ducts are undersized, and they use their thermostats, using the gas pedal method of turning it down super low and trying to control, and it's it's just really unfortunate. You know, I have about 20 years experience designing heating and cooling systems for new construction production homes, and you know, we were very conscientious. We were the very few companies that did a full-blown active manual JSMD and had really good results in terms of customer service. And these people in these homes just essentially just turned it on, and the house was comfortable, and they forgot about it. But you know, older homes and homes that weren't designed properly, people are they're just not happy, and they try to overcompensate, and it just makes things worse. It's tough. You know, even the good news is that the shell is getting so much more efficient that it's less prone to problems than a shell that was, you know, single pane aluminum frame windows and the house leaked like crazy. There's literally the inside of the house is better insulated from the outside, so it reacts better. It's not, you don't have the temperature fluctuations that you have. It's not as sensitive to poor thermostats. So that's been an improvement. But the existing housing stock is really horrible out here in California because of, you know, people think it's the ideal weather conditions, and people were just really sloppy with the design of the houses for so many years. But the home performance and the building performance industry is improving the existing housing stock. Utilities are really on board with things like we have a statewide program called Energy Upgrade California, where they're improving the building shell. We're trying to train HVAC contractors to you know, don't just swap out equipment like for like. Is you know, look at the house. You know, the furnace may have been in the house for 10 years, but you know, 3 years ago they replaced all the single pane aluminum windows with dual pane vinyl windows, and now the furnace and air conditioner is broken down, and the contractor just wants to come along and just change out like for like, you know, put in the same size equipment. But don't do that. Look at the house. Say, you know, this house is way better than it was when the equipment was originally put in. So let's do a load calculation. Let's see if we can put a smaller system in there and you know, use less energy, use less peak load, and do all the right things. And slowly but surely, you're starting to see that.
And you think, in your experience, you had said that most duct systems are undersized. So when you, in fact, downsize the equipment, you're saying that actually now the duct system, it's almost like it was designed perfectly?
Yeah. You're downsizing the equipment to fit the ducts that you know, should have been sized for a smaller equipment. But you know, that is a true statement. I'm hoping that especially in some of the older houses, that they're replacing the ducts as well. That's a fairly common thing, is to reduct a house, because you know, so many of the there was a really bad batch of flex duct that got installed in hundreds of thousands of houses in California, and it just disintegrated. Plus, a lot of sheet metal ducts is just falling apart. So reducting is pretty common.
Huh. So aside from the window placements and the HVAC professionals even, and all this stuff that we've been talking about, the real bottom line is we need to have actual homeowners and normal people understanding that they need to ask for this stuff. And it seems like you spend a fair amount of your energy trying to explain home performance to normal people. What's your experience been with how that effort is going?
It's interesting. You know, I've given seminars at home shows and things like that. I tested out a program called Comfort Geek, where you know, it was all about it was called Home Comfort Diagnostics, and it was going into a house and you know, diagnosing the house and you basically doing a residential air balance report and then making recommendations to improve it and stuff like that. And the people that listened were the cream of the crop in terms of the public. You know, it's the people who already sort of had an interest in that topic were very interested in it, and the people who had no interest in it were off doing other things, playing golf or whatever. You know, it's hard to break into the I guess you want to call it the average homeowner to get them to understand and appreciate this stuff. What's kind of interesting is my wife's a school teacher, and she teaches fourth grade and sixth grade. She taught sixth grade for a long time. That was a great audience. Is my wife would have me come in and do an hour presentation, and I'd have all the kids raise their hands. How many people know what a furnace is, and where is it, and what are those little things in the ceiling where the air comes out, and I felt like I was really getting somewhere with those kids. They'd come back and tell my wife, wow, I knew more about my house than my dad did, and stuff like that. And,
we just got to figure out a way to give mortgages to kids now.
Yeah, exactly, yeah. So, I'm sorry I drifted away from your question, but no, I think I think it's just constantly chipping away at the stone, and hopefully finding that it's weird. It's like how does a video turn viral? What is the magic elixir that causes something to become a fad or popular all of a sudden, where people just sort of start buying into it? You just got to keep chipping away at it.
Yeah, persistence. Awesome. Well, Russ, thank you so much for talking with us today.
Oh, my pleasure. I enjoyed it.
Russell King is the owner of Sierra Building Science Incorporated. You can find his writing at sierrabuildingscience.com. You have been listening to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Tune in next time.